Hello class 11 science. Today you are going to discuss about the topic exception to the octet rule. In the previous classes we have seen the covalent bond formation and we have seen the various compounds like methane, ethane, water molecule, ammonia. Now if you notice in all this structure the central atom has got 8 electrons. That means while sharing the electrons they had acquired 8 electrons on the central atom and to other also, okay, except hydrogen which only needs only 2 electrons. Okay. Now but there are some compounds where it forms a compound but the central atom or the other atom does not have 8 electrons. Let us see what are they. So limitation of the octet rule. Octet rule could not explain the formation of electron deficient molecules such as beryllium chloride, boron trifluoride, ammonium trichloride, etc., in which the central atom has less than 8 electrons in its valence shell. For example, in BeH2 and BeCl2, the central beryllium atom has 4 electrons in the valence shell, while boron atom has 6 electrons in its valence shell. Okay, now when you consider this BeH2, so beryllium in the outermost has got 2 electrons and hydrogen has got one electron. Now while they form a covalent bond, they will share one electron pair to each other. In doing so, the central atom does not have 8 electrons. It has only 1, 2, 3, 4. Okay, so this is the limitation of octet rule. Similarly with this beryllium chloride also. Now when you talk about boron trifluoride, in boron in the outermost we have got 5 electrons. Sorry, we have got 3 electrons because boron atomic number is 5, so 1s2, 2s2, 2p1. So in the outermost we have got 3 electrons and fluorine has got 7 electrons in the outermost. So while sharing the electron, when they form a covalent bond, the boron atom does not have 8 electrons, which is the octet rule. It has got only 6 electrons. So these are the limitations of octet rule. Similarly, when you see for aluminum trichloride also, the central atom aluminum does not have 8 electrons. Okay. Now if you go for another compound, say for example PF5, phosphorus pentafluoride. So in phosphorus, in the outermost we have got 5 electrons. Okay, 5 electrons in the outermost, and fluorine has got 7 electrons. So while sharing the electron of each, this phosphorus atom at the center will have 10 electrons because that 1 electron will be shared with each fluorine atom. So altogether when it's shared with 5 it becomes 10 electrons, which is again more than 8 electrons. Similarly with SF6 also, sulfur hexafluoride, it has got 6 electrons in the outermost, so it will share its 1 electron with the 6 fluorine atom and the number reaches to 12, we can say. Okay, the number reaches to. Similarly with IF7, where the central atom will have 14 electrons. So these are the limitation of the octet rule because the central atom does not have only 8 electrons. So today's assignment 8, identify the atoms in each of the following which do not obey the octet rule: sulfur dioxide, SF2, SF4, SF6, OF2, PCl3, PCl3. So out of this you have to identify the atoms which does not follow octet rule. That means the central atom does not have 8 electrons. Question number 2 is, draw the Lewis structures of the following, or Lewis structure or electron dot structure. Fluorine, just corrected. Okay, just corrected the formula. Fluorine F2. Okay, we just write F2. Phosphine PS3, hydrogen sulfide H2S, nitrogen trifluoride NF3, and oxygen difluoride OF2. Okay, got it? Once again I am repeating, just correct it. Fluorine F2, phosphine PH3, hydrogen sulfide H2S, nitrogen trifluoride NF3, and oxygen difluoride OF2. So you need to draw the electron or Lewis dot structures. Please complete the assignment and send it in my mail.